it is a rod. It is a rod. In the question, rod is moving. Rod is moving with acceleration A. This rod is moving with acceleration A. And here we have a ring. Here we have a ring. Mass of the ring is given M. Mass of the ring is given M. Note on the question. If rod is moving with acceleration A, if rod is moving with acceleration A, then find acceleration of the ring, with respect to rod. Then find acceleration of the ring with respect to rod. So in the question, so here mass of the ring is given M. So it is a rod. A rod is moving with acceleration A. So in this case, rod is the non-inertial frame. In this question, rod is non-inertial frame of reference. Non-inertial frame of reference. In the case of non-inertial frame of reference, along with real forces, also we have to consider a pseudo force. So here M is mass of the ring, it's a weight mg, and so in the question this angle is given theta. This angle is given theta. So mass of the ring M, its weight mg, so weight direction vertically downwards. Now this component of weight of the ring is mg cos theta. It is mg cos theta. Then after mg sin theta down the inclined plane, it is mg sin theta. So then after here, so rod is a non-inertial frame. In the case of non-inertial frame, so we have to consider pseudo force also. Okay, so how to draw pseudo force? That is opposite to acceleration of non-inertial frame. Non-inertial frame acceleration leftwards, non-inertial frame acceleration leftwards. So pseudo force rightwards. Pseudo force direction rightwards. It is pseudo force. And how to find pseudo force? What is the formula we have? Pseudo force equal to minus already here we followed, minus opposite direction already we followed. So M into acceleration of non-inertial frame of reference. In this case, so A is the acceleration of non-inertial frame of reference. So it is ME, and this angle is a theta with horizontal. If this angle is a theta with horizontal, this angle also theta. So it is the pseudo force. Now this pseudo force resolve into components. Now this component of pseudo force is MA cos theta. This component of pseudo force MA cos theta. Then after this component of pseudo force is MA sin theta. And as rod is moving horizontally, so generally here the ring slides downwards. So it is the direction of motion of the ring. Ring is sliding downwards. Okay, so it is a direction of motion of the ring. It is direction of motion of the ring. So here, now you please answer in this question. So you please answer. If ring is moving downwards, so along the direction, how many forces are present?
Two
forces. One is mg sin theta and one is ma cos theta. Then how to find resultant force? MA cos theta minus mg sin theta?
mg sin theta
mg
minus
sin
mg
theta
minus
minus
MA cos
MA.
theta.
So resultant force is equal to mg sin theta minus MA cos theta. Resultant force means what is the formula we have? Mass into acceleration. So what is the mass of the ring? Is A, but this acceleration is acceleration of the ring with respect to rod. Why? Because in this case, a ring is moving on the ground, a ring is moving along the rod. This ring is moving along
Along
the
rod.
So here, whatever the direction or whatever the motion, so this motion is along the rod. Okay. So whatever the motion is along the rod. So resultant force means mass into acceleration, but this acceleration is acceleration of the ring with respect to a rod, because the ring is moving along the rod. Equal to, on right hand side, we have mg sin theta minus, sorry, it is MA
So
cos
it should
theta.
cos theta, right?
Cos theta.
Cos theta.
So it is MA cos theta. Now on both sides, what is the cancellation term?
M.
On both
M.
sides, M cancels. Therefore, what is the final equation? Acceleration of the ring. Acceleration of the ring with respect to rod equal to g sin theta minus A cos theta. So this is the question. And what is the question? What we have to find acceleration of the ring with respect to rod. The same thing we got it. That is g sin theta minus A cos theta. Completed?
So 1 minute, please.
1 minute.
Sir,
Please.
can you scroll up once? Thank you, sir.
Note and fast. Okay.
Sir, done.
Done, sir.
Right on. Next question. Okay, same thing regarding non-inertial frame question. For example, here it is inclined plane. If this angle is theta, so generally we know gravity vertically downwards. It is gravity direction. Now this component is g cos theta. In the same way, this component is g sin theta. So these are the components we have. The question is, so on the inclined plane, a car is moving down with uniform velocity. In the question, it is given, car is moving down with uniform velocity. So in the car, a pendulum is suspended. So a pendulum is suspended, and the pendulum is deflected through angle theta naught. The pendulum is deflected through angle theta naught. So find theta naught. Find theta naught. So in the question, the car is moving down the inclined plane with uniform velocity.
Sir, but if the car is moving down, then the pendulum must be suspended backward, no?
Oh, let us see here. Let us see. Now, what is the theta naught value? The pendulum will be exactly like this, or moving forward, backward. Let us find out. Okay.
Okay,
So, for
sir.
example, at this position, if m is mass of the pendulum, m is mass of the pendulum, its weight mg, and what is the mg direction? Vertically downwards. Now, this component is mg cos theta. This component is mg cos theta. Then after, this component is mg sin theta. This component mg sin theta already be represented here. It is g cos theta. So it is g cos theta, so mg cos theta. It is g sin theta, so down the inclined plane mg sin theta. Then after, so here with respect to pendulum, what is the direction of tension force? Away from the pendulum along the string. Okay, away from the pendulum along the string. So here it is the direction of tension force. It is the direction of tension force. Then after, so here this angle is given theta naught. If this angle is given theta naught, now you please answer, what is the angle over here? If
Theta
this
naught.
angle,
Theta not only.
Alternate angle.
Interior
Theta naught.
alternate angles.
So here, so then what about this component? T cos theta naught or T sin theta naught?
T cos theta not.
T cos theta naught. And it is T sin theta naught. Okay, just a minute. Okay, exactly opposite. Okay. Now this component is T sin theta naught. So in the question, it is given that it is moving down the inclined plane with uniform velocity. So with uniform velocity means, so do we have any acceleration will be present?
Zero.
Zero acceleration.
Okay, so this component is T sin theta naught. So here it is moving down with uniform velocity. With uniform velocity, acceleration 0. With acceleration 0, resultant force 0. If resultant force 0, then the forces will be
Balance.
balanced. So what are the balanced forces here?
Mg sin theta naught equals T sin theta naught.
So here T sin theta naught is balanced by mg sin theta. In the same way, what is the one more balanced force? T
cos theta,
cos
mg
theta
cos
naught
theta.
is balanced by mg cos theta. So these are the balanced forces. Then after, by dividing both equations, so T cancel out, mg cancel out, sin theta by cos theta naught is tan theta naught, equal to sin theta by cos theta is tan theta. So therefore tan function cancel out, so theta naught equal to theta. Okay, that means what is the angle of deflection of the pendulum? So here, what is
Equal
it?
to the angle of inclination.
Correct. Note down, please.
Sir, this is possible only if it is moving with uniform velocity, no?
Uniform velocity. Correct.
Sir,
Please.
after you resolved tension force into the components, could you please repeat once?
So it is given uniform velocity. The car is moving with uniform velocity.
Yes, sir.
Okay, that means what about acceleration of this pendulum? Zero. If acceleration 0, forces will be balanced in all directions or not?
Yes, sir.
Yes,
So here, in this direction, what are the balanced forces? T sin theta naught balanced by mg sin theta. T cos theta naught is balanced by mg cos theta.
Yes,
Then dividing
Excuse
both
me, sir.
equations.
Hello, sir. Sir,
Please.
sir, actually, I am Harsh, sir. I got disconnected because of network issue. Can you tell me what did you teach in last 5 minutes?
I done 2 questions. That's it.
Okay, sir.
Just leave one page. That's enough. Yeah, write down
Thank you,
next
sir.
question.
So one second, please.
Write down fast. Okay, note down please. Next question. So for example, it is inclined plane. So theta is angle of inclination and a car So in the question, it is given that car is moving down the inclined plane with acceleration g sine theta. Car is moving down the inclined plane with acceleration g sine theta. So in this question, the car is non-inertial frame of reference. Car is non-inertial frame of reference. Why? Because car is having some acceleration. So car is the non-inertial frame of reference. So from this car, so one pendulum is suspended. Pendulum suspended in the car. And for example, the pendulum is deflected through angle theta naught. Deflected through angle theta naught. So the question is find theta naught. The question is find theta naught. So here angle of inclination is theta. Angle of inclination theta. So here m is mass of the pendulum. So weight mg vertically downwards. And this component of weight mg cos theta. Okay, like same previous question. It is mg cos theta and this component is mg sin theta. This component is mg sin theta. Then after with respect to pendulum, so here it is the direction of tension force. So it is the direction of tension force and this angle is a theta naught. Now this angle also same theta naught. Now this angle theta naught. Now this component of tension force is T cos theta naught and this component of tension force is T sin theta naught. Then after, so here it is a car is a non-inertial frame. So car is a non-inertial frame. In the case of non-inertial frame, along with real forces, pseudo force also present. But how to draw pseudo force opposite to acceleration of non-inertial frame? So here non-inertial frame moving down the inclined plane. So this non-inertial frame acceleration down the inclined plane. So pseudo force will be in opposite direction. So it is a pseudo force. So how to find a pseudo force? That is MA and A value already given mg sine. So it is a pseudo force MA and A value already given g sine theta. So in this case, car is a non-inertial frame. In the case of non-inertial frame, along with real forces, pseudo force also present. How to draw pseudo force opposite to acceleration of non-inertial frame? Non-inertial frame acceleration down the inclined plane. So pseudo force opposite direction. That means up the inclined plane. That is MA. And A means acceleration of non-inertial frame. So what is the acceleration of non-inertial frame? That is g sine theta. Okay. Now we have to find a theta naught value. For example, here I'm taking observer is inside the car. Observer. So observer is inside the car. Okay, that means observer also in the same frame. Observer also in the same frame. Now you please answer. So observer also in the same frame. Now with respect to observer, now the pendulum is in acceleration or at rest position. Observer in the same frame.
Rest.
Rest.
Yes.
Okay, so
At an instant,
now,
it's at rest.
so here observer is also in the same frame. So with respect to observer, the pendulum is at rest position. If the pendulum is at rest position, same thing, forces are balanced. So we have to balance forces and we have to find theta naught value. Okay, write down. Here observer, here observer, here observer and pendulum, observer and pendulum in the same frame. Observer and pendulum in the same frame. So with respect to observer, with respect to observer, pendulum is at rest position. Pendulum is at rest position. So forces acting on the pendulum. So forces acting on the pendulum. Forces acting on the pendulum will be balanced. Forces acting on the pendulum will be balanced. So here, what are the balanced forces? First of all, T cos theta naught. So T cos theta naught is balanced by mg cos theta. So first one is T cos theta naught. T cos theta naught is balanced by mg cos theta. Then after, we have one more set of balanced forces now in this direction. So what are the balanced forces? That means how many forces down the inclined plane and how many forces acting up the inclined plane, they will be balanced. So forces acting down the inclined plane balanced by forces acting up the inclined plane. That means mg sin theta is balanced by T sin theta naught plus MA. So here MA is the pseudo force. This MA is a pseudo force. So therefore, that implies mg sin theta equal to T sin theta naught plus M into, so A means acceleration of non-inertial frame. A means acceleration of non-inertial frame, that is given in the question g sin theta. You refer the question. In the question, what is the acceleration of non-inertial frame? That is given g sin theta. So in the place of A, g sin theta. Therefore here mg sin theta cancel out on both sides. Now after cancellation, we have T sin theta naught equal to 0. That means sin theta naught equal to 0. That means theta naught value is 0 degrees. So this is the question. Okay. Right now, next question. Next question. So we have inclined plane. We have inclined plane. And in the question, theta is angle of inclination. Now on this inclined plane, a trolley so it is a trolley. So from the trolley, a pendulum is suspended. From the trolley, a pendulum is suspended. And in the question, okay, so it is a trolley. In the question, it is given that this trolley is moving up the inclined plane with acceleration A. Moving up the inclined plane with acceleration A, and this angle is, for example, theta naught. So find theta naught. Find theta naught. Find theta naught. So the pendulum the pendulum deflected through angle theta naught. We have to find theta naught value. In the question, this trolley is moving up the inclined plane with acceleration a, and we have to follow same logic. So first of all, it is mg, so the weight vertically downwards. This component is mg. Then after, this component is mg cos theta. This component is mg cos theta, and this component is mg sin theta. Okay, this component is mg sin theta. Then after, in the question, trolley is non-inertial frame. So trolley is non-inertial frame of reference because acceleration is given. In the case of non-inertial frame, along with real forces and pseudo force also we have to consider. In the same way, now with respect to pendulum, so here it is the direction of tension force in the string, let it be T. Okay, if this angle is a theta naught, that means here this angle also theta naught. Now this angle also theta naught. Now this component of tension force T cos theta naught, and this component of tension force is a T sin theta naught. This component is T sin theta naught. Then after, along with real forces, pseudo force also will be acting on the pendulum. So how to draw pseudo force? Opposite to pseudo force can be drawn opposite to acceleration of non-inertial frame. So here, what is the acceleration of non-inertial frame of the inclined plane? Acceleration of non-inertial frame of the inclined plane. So pseudo force will act in opposite direction. So that means down the inclined plane, pseudo force will be present. And how to find pseudo force? Mass into acceleration of non-inertial frame. So it's the FBD, free body diagram of the pendulum. So we have gravity, so we have weight and weight components, tension force components. So trolley is a non-inertial frame. So pseudo force also we have to consider. For example, I'm taking observer also in the same frame. Observer, so he's observer also in the same frame. So in this case, observer and pendulum are in the same frame. So that frame is a trolley frame. So in this case, observer and pendulum are in the same frame. So therefore, with respect to, so if both are in the same frame, so with respect to observer, pendulum will be at rest position. If pendulum is at a rest position, forces acting on the pendulum, balanced. So now we have to identify the balanced forces. First of all, here T sin theta naught. So the question is, we have to find the theta naught value. Now this is our question. We have to find the theta naught. So therefore, forces acting on the pendulum are balanced, means T sin theta naught. T sin theta naught is balanced by mg sin theta plus ma, pseudo force. So the first set of balanced forces, T sin theta naught is balanced by mg sin theta plus ma. So here ma is a pseudo force. So it is a pseudo force. Then after, what is one more set of balanced force? T cos theta naught balanced by mg cos theta. So next set of balanced force, T cos theta naught is balanced by mg cos theta. The question is, we have to find a theta naught. To find theta naught, simply do one thing, divide both equations. I'm dividing both the equations. So T sine theta naught upon T cos theta naught equal to, on right hand side, division mg sine theta plus MA upon mg cos theta. So we are dividing both equations. Left side TT cancel out. Now sine theta naught upon cos theta naught. Sine theta naught upon cos theta naught is nothing but tan theta naught. On right hand side, m is the common, cancels. M is the common and cancels. So finally we have g sine theta plus A upon g cos theta. But the question is, we have to find a theta naught. Therefore, from this equation, finally we have theta naught equal to tan inverse of g sine theta plus A upon g cos theta. Now this is the process of finding theta naught. So do you have any doubt in this question? There is no new point. The only thing is we have to consider pseudo force. That's it. Okay. Over.
Sir, what if the observer is not in the frame of reference? Is this in the same frame of reference then?
So for example, if observer is not in the same frame, then we have to take observer on the ground. For example, if observer is on the ground, okay, if observer is on the ground, if observer, I'm taking like this, just a minute. So here it is an inclined plane. Then after it is a trolley. And here a pendulum is suspended. Pendulum is suspended. So we have this component is mg sine theta, this component mg sine theta, and this component is mg cos theta, and this component is t cos theta naught, and this component is t sine theta naught. T sine theta naught. So I'm taking observer, and in the question, this trolley is moving up the inclined plane. It is moving up the inclined plane. So in this case, for this observer, if the trolley is moving up, the inclined plane, this pendulum also seems to be moving up the inclined plane, correct?
Yes.
For this observer, so if the trolley is moving up the inclined plane, so this pendulum seems to be moving up the inclined plane. If the pendulum seems to be moving up the inclined plane, now in this direction forces will be balanced or not?
Yes, sir.
Okay, so then what are the balanced forces we have? T
Cos theta is equal to
cos
mg
theta
cos.
naught equal to mg cos theta, correct?
Yes.
Now for this observer, now this pendulum seems to be moving upward of the inclined plane. So for this observer, this pendulum seems to be moving up the inclined plane. Then what is the resultant force acting on the pendulum?
T sine theta minus mg sine theta.
So resultant force is T sine theta naught minus mg sine
T
theta
sine theta.
is the resultant force. Resultant force means
Mass
into
acceleration.
acceleration. Therefore, from this equation, T sine theta naught, this negative value to right hand side becomes positive. Now we have MA plus mg sine theta. You verify with the previous solution, the same equations we got it, or the different equations we got it.
Same equation.
So got it now, the method?
Yeah. Yes, sir. Yes, sir.
Okay, so that's up to you taking the same frame, observer in the same frame or in the different frame. That's up to you. So whatever you feel comfortable, you follow it. The thing is, for example, if I'm taking observer in the same frame, in the simplest way, with respect to observer, the pendulum seems to be at rest position, simply balance forces. Okay, so it is more easier in spite of taking observer on the ground. So taking observer in the same frame, that is much easier. If observer in the same frame, simply here with respect to observer, the pendulum will be at rest position. So simply balance forces and do the simplification. Okay.
So when observer is on the ground, don't we need to take that pseudo force?
No, no. Why? Because ground is what type of frame?
Inertial, yeah. IFS.
Inertial
Inertial
frame.
Yeah. Okay,
Got
sir.
it, no?
Yes.
Right now, next concept.
Can
Sir,
you 1 second show that up what you did, the second method? 1 second. Yes, sir. Thank you.
Note it down.
Yes, sir.
Okay.
Sir, can you please do a bit more?
Sorry.
Can you please do a bit more?
Some more.
Yeah, right now. Next one is wedge normal constraint. Wedge normal constraint. Wedge normal constraint. Write down for statement, then we will do examples. If two objects are in contact, if two objects are in contact, are in motion. Now the two objects are in motion and the two objects are in contact each other. Now component of, then the components of velocities or accelerations along the normal to the contact surface, must be equal. So here it is a normal constraint. So what is a normal constraint? If two bodies are in contact, and two bodies in motion. So two bodies in contact, that the two bodies in motion. Now what are the velocities and acceleration along the normal? This normal should be drawn to the contact surface. So velocities or accelerations along the normal to the contact surface must be equal. Why must be equal? If velocities and acceleration along the normal, if they are equal, then only they keep contact each other. Otherwise, if velocities and acceleration along this normal are different, then they don't maintain contact. So the two objects are in contact. So two objects in contact means along the normal direction, velocities or accelerations must be equal. If this condition satisfies, then only the two objects can maintain contact. Otherwise, they lose contact. So it is a wedge constraint. Write down first example. So it is a wedge, for example. So it is a wedge. And in the question, this wedge is moving with velocity v. This wedge is moving with velocity v. So just to give me 1 minute time to draw the figure. So these are the supports. These are the supports. And in between them, we have a rod. In between them, we have a rod. So in the question, it is moving down. This rod is moving down with 10 meter per second. Moving down with 10 meter per second. Find v velocity. We have to find the velocity of the wedge. And this angle is 37 degrees. This angle is 37 degrees. So here, if the rod is moving down with 10 meter per second. So here it is a smooth surface. It is smooth surface. That means now this wedge we kept on the smooth surface. Whenever it is moving downwards, this wedge starts moving rightwards. The wedge starts moving rightwards. Now we have to find the velocity of the wedge. And in this question here, the two surfaces in contact. So it is a contact surface. It is a contact surface. Now the two surfaces in contact. So here we have to follow wedge constraint. We have to follow wedge constraint. So see carefully. It is a contact surface. It is a contact surface. Then after 10 meter per second exactly vertically downwards. It is 10 meter per second. So if this angle is at 37 degrees, now this angle also becomes 37 degrees. This angle also 37 degrees. So it is a contact surface. It is a contact surface. But according to wedge constraint, which portion we have to consider normal to contact surface. Normal to contact surface. So in this normal direction, velocities or accelerations must be equal. Then only the two bodies, they maintain contact each other. If the conditions are not satisfied, they lose contact. Okay. So to maintain contact in this normal to the contact surface, in this normal direction, velocities or accelerations must be equal. If it is a 10 meter per second, now this component is a 10 cos 37. This component is a 10 cos 37. Now this component is 10 cos 37. Now 10 sin 37 not necessary. Why? Because only along the normal. So in the question along the normal, the velocities or accelerations we have to consider. Okay. Then after. So wedge velocity is exactly horizontal. So it is velocity of the wedge. It is velocity of the wedge. So if this angle with horizontal 37 degrees, now this also 37 degrees. This also 37 degrees. Now this velocity resolve into component. Now this component is v cos 37 degrees. And this component is v sin 37 degrees. So here, so v means velocity of the wedge. With horizontal, this angle 37 degrees. Now this angle also 37 degrees. This velocity resolve into component. So it is v cos 37. It is v sin 37. Now you please explain. You please explain. So to this contact surface, it is a normal. It is a normal. What is the wedge normal constraint? What is the normal constraint? In the normal direction, velocities or accelerations must be equal. Okay, that means what are the velocity components are equal? What are the velocity components are equal over here? V sin 37. Please. V sin 37 is balanced by 10 cos 37. Along the normal, see, along the normal velocities or accelerations must be equal. So these two velocities we are equating, and do simplification. Let me know the final answer. So what you got? So here, first of all, you identify the contact surface. To this contact surface, you draw the normal. To the contact surface, you draw the normal. So in this normal, velocities, accelerations, equating them. That's it. It is a contact surface. To this contact surface, first of all, you draw the normal. So it is a normal. In this normal direction, what are the velocities are present? We have to equating them. It is 10 meter per second. So 10 meter per second. This angle 37 degrees. So 10 cos 37. Now it is one velocity component in the normal direction. Then after in the question, V is velocity of the wedge horizontally. So V is the velocity of the wedge horizontally. Now this angle 37 degrees with the horizontal, same thing with horizontal 37 degrees. Now this V velocity resolve into components. Now this component is V cos 37. Now this component is V sin 37. So here for this contact surface, it is a normal. Now in this normal, what are the velocity components are present? They must be same. So V sin 37 must be equal to 10 cos 37. And you simplify, find out V value.
Sir,
Velocity 40 by 3.
40 by 3.
sir,
Right? Please.
you have written no, those two angles 37 degree. I did not understand how it became 37 degree.
Do you know properties of triangle at least? You are the
Yes.
mathematics students. Okay.
Yes, sir.
So if this angle is 37 degrees, this angle 37 degrees, what is the angle over here? What is the angle over here, man? Trigonometry completed?
Yes, sir. Okay.
53.
53.
minus 37.
So this is 53 degrees. If this is 53 degrees,
90 minus 37. Yeah.
now what about this angle? If this is 53 degrees,
37.
so I think 37 degrees.
Okay.
If it is a 53 degrees, it is 37 degrees. Same thing, 37 degrees. Correct?
Sir,
Please,
sir,
what is the
could you show the thing you wrote up?
What's your name?
Rahil, could you show the thing what you wrote up?
Oh, what's your name first of all?
My name is Rahil.
So if this angle is 37 degrees, what is the angle over here? Rahil, what is answer here? What is the angle
No,
over
sir.
here?
Sir, I don't want this. I want the thing you wrote up.
This one?
No, yeah, this one. 1 minute, sir. Yes, thank you.
Right now, next example. So for example, it is a vertical surface. It is a horizontal surface. Okay, and they are smooth surfaces. They are smooth surfaces. And here, it is a body. It is a body. Then after, and here we have it is another body. So like this, we have two different bodies. So in this question, it is a contact surface. So the two surfaces in contact over here, the two surfaces in contact. And in the question, this angle is given 37 degrees. This angle is given 37 degrees. If this vertical block, this block is moving down, if this block is moving down with 10 meter per second, 10 meter per second. Now, if this block is moving down with a 10 meter per second, so what about this horizontal block will move?
Rightward with 10 meter per second.
Rightward with velocity v. So this velocity v we have to find out. Velocity v we have to find out. Okay, listen. In this case, it is a contact surface. It is a contact surface. I'm drawing contact surface separately. It is a contact surface. Then after, for this contact surface, okay, the same part I'm drawing in the zoom, in the bigger view. Okay, the same contact surface I'm drawing in the bigger view so that it will be very easy to understand. Then after here, this angle is 37 degrees is given in the question.
चाकितेनी मार दिल्ली खींच के तमाचा ही नाच दे.
कौन कर रहा है?
And in the question, this angle is 10 meter per second exactly vertically downwards. 10 meter per second exactly vertically downwards. I told you already, if this is equal to 37 degrees, now this angle also equal to 37 degrees. This also 37 degrees. Now this 10 meter per second resolve into components. Now this component is 10 cos 37 degrees. Therefore, for this contact surface, so here for this contact surface, it is a normal. Now in this normal, we have one velocity component. For this contact surface, it is a normal. Along this normal, we have one velocity component. If this angle 37 degrees, this also 37 degrees. Now this component is 10 cos 37 degrees. Then after, so this v velocity exactly horizontal. This v velocity exactly horizontal. So it is v velocity exactly horizontal direction. So this angle 37 degrees, so that this angle also 37 degrees. Now this v velocity resolve into components. V velocity resolve into components. Then what we get? One component is v cos 37. Now this component is v cos 37 degrees. And in the same way, this component is v sin 37 degrees. V sin 37 degrees. And so it is a contact surface. For this contact surface, it is a normal. And what is the normal constraint? In the normal direction, velocities must be equal. So equating them. So v sin 37 degrees equal to 10 cos 37 degrees. You simplify it, find v value. Write down. Next, one more question. So answer is correct, 40 by 3 meter per second, correct. Write down next question. So in the next question, it is a smooth surface. And here it is a vertical surface, a vertical wall. So it is the horizontal surface. It is a horizontal surface. Then after here we have a triangular shaped wedge. Triangular shaped wedge. And in the question, this angle is given theta. Then after here, we have a rod. Here we have a rod. And in the question, this rod is moving downwards. This rod is moving downwards with acceleration a1. So it is smooth surface. It is a smooth surface. So when the rod is moving downwards, this triangular wedge will move leftwards. It will move leftwards with acceleration a2. With acceleration a2. The question is find a2. Find a2 in terms of a1 and theta. Find a2 in terms of a1 and theta. So in this question, first of all, let us identify the contact surface. So here it is a contact surface. So if it is a contact surface in the normal direction, so here accelerations must be equal. It is a contact surface. For this contact surface in the normal direction. So accelerations must be equal. You try this question as a homework. So here, as the rod is moving downwards, with acceleration a1, this triangular wedge will move leftwards. With acceleration a2. So we have to find a2. In terms of e1 and theta. It is the contact surface. To this contact surface, you draw the normal. Now in this normal direction, so what are the accelerations are present? Equating those acceleration, and you try this question as a homework. Write down one more question. So here, for example, three identical spheres we have. Three identical spheres. Identical means same radius. We have three identical spheres. Okay, so just a minute, please. Just a minute. So three identical spheres and all the surfaces in contact. And radius of each sphere same. Radius also given same. So in the question, it is given that if this sphere is moving downwards with acceleration a1, this sphere is moving downwards with acceleration a1. Now this sphere will move leftwards with acceleration a2. Same thing, this also move leftwards with acceleration a2. So here, this sphere is moving down with acceleration a1. Now the two spheres will move leftwards, rightwards with the same magnitude of acceleration. So find out a2 value. Find a2 in terms of a1. Find a2 in terms of a1. find A2 in terms of A1. And in the question, all these are identical spheres. Identical means same radius. Identical means same radius is given. Same radius means what type of triangle it is. It is equilateral. It is equilateral triangle. Equilateral triangle. If it is equilateral triangle, so here this angle is 60 degrees. This angle 60 degrees, and this angle totally 60 degrees, and this is this angle. So it's the bisector angle 30 degrees. It is 30 degrees. And same thing here, this angle is 60 degrees and this angle is 30 degrees. So it is 30 degrees totally 60 degrees. So what type of triangle it is? Equilateral. So all the three angles must be same. So this sphere is moving down with acceleration A1. Now we have to find the A2 value. We have to find the A2 value in terms of A1. Now this is the question. It's very simple one. To find A2, for example, that's up to you. I'm taking this combination. So taking this combination of spheres or this combination of spheres, that's up to you. So you follow anything. So I'm taking these two spheres. I'm taking these two spheres. So here is one sphere. Then after here, one more sphere. And this sphere is moving downwards with acceleration A1, and this sphere is moving leftwards with acceleration A2. And this angle, so here, first of all, we have to identify the contact surface. So it is a contact surface. It is a contact surface. And this angle we know already, this angle is 30 degrees. If this angle 30 degrees, A1 resolve into component. Now this component is A1 cos 30. This component of acceleration is A1 cos 30. Now this component of acceleration is present along the normal to the contact surface. For this contact surface, okay, this component of acceleration is normal, in the normal direction. Okay, in the same way, this angle already we have, it is equal to 60 degrees. It is equal to 60 degrees. If it is equal to 60 degrees, now this angle also same thing, 60 degrees. Then after this A2, okay, this component, this acceleration A2 resolve into component. Now this component of acceleration is A2 cos 60 degrees. This component of acceleration A2 cos 60 degrees. Therefore, in this figure, it is a contact surface. It is a contact surface. For this contact surface, it is a normal. It is the normal. In this normal, so what are the accelerations are present? They must be same. Along the normal, what are the accelerations are present? They must be same. One acceleration is A1 cos 30, A1 cos 30, and along the normal, one more component is A2 cos 60. So along the normal, the accelerations must be same. Therefore, A2 into cos 60 means 1 by 2 equal to A1 into cos 30 means root 3 by 2. So 2 cancel out. Therefore, we have A2 equal to root 3 times A1. Now, this is the question. And what is the question? We have to find A2. We have to find A2 in terms of A1. So finding A2 in terms of A1. So here, in this case, it is one component of acceleration. Is one component of acceleration, that is A1 cos 30. This A1 cos 30 is equal to A2 cos 60, and simplify it. Right now, next concept, very important one. Next concept. Pulley wedge constraint. Next one is pulley wedge constraint. Pulley wedge constraint. Okay, so it is very important for competitive point of view. So they ask the questions up to advanced level in this concept. For example, here it is a support and a horizontal surface. So vertical surface and it is horizontal surface. So if the logic is clear, now we can do this type of questions very easily. If the logic is very clear, the only thing is, so we have to understand the logic. So on this horizontal surface, here we have a wedge. Here we have a wedge. And in the question, this angle is given theta. Now it is ideal pulley. And here we have the string. And the string is fixed here. String is fixed here. String is fixed here. Okay. So this string is connected to a block. This string is connected to a block. And the question is, if this wedge is moving to left side with velocity v. Wedge is moving to left side with velocity v. So it is the first example right now. So this wedge is moving to left side with velocity v. Now the thing is, if the block is always in contact, the block is always in contact with wedge, then find velocity of the block. Find velocity of the block. So in this question, this block is not losing contact. It is not losing contact. So block is always in touch. So block is always in contact with the wedge. So here in this case, if the wedge is moving to left side, now we have to find out velocity of the block. So you try to get this point. For example, it is at the time t equal to 0, the wedge over here. At the time t equal to 0, the wedge over here. After some time, for example, the wedge traveled a distance x. After some time, wedge traveled through distance x. Now here, this is the string. Now here, this is the block. Okay, so you please answer. In this case, if the wedge is moving to left side, this block will move along the inclined plane Will move down the inclined plane or will move up the inclined plane?
Down the inclined plane.
Down the inclined plane.
Plane. For example, in this case, the wedge traveled distance x. Wedge traveled distance x, and the block slides down through distance y. Block slides down through distance y. So in this case, when the wedge is traveling through distance x and the block is moving down the inclined plane. So block is moving down the inclined plane through distance y. In this case, just imagine that if, so I'm taking here initially, you focus on this white color portion initially. So when the wedge is traveled through distance x, now this is segment length increases or decreases. The wedge is moving from here to here.
Decreases.
Okay. So the wedge is moving from here to here.
कुत्ते की मौत जग में सब कहेंगे मर गए.
They don't know the values. So in this case, the wedge is traveling through distance x. So if I'm taking it is the first segment, it is the first segment of the string, it is second segment of the string. So it is the first segment of the string. So here I'm taking it is the first segment. It is the first segment I'm taking. Then after it is the second segment I'm taking. And we know string is always ideal, means total length is always constant. So it is the first segment of the string, it is second segment of the string. Now because of the motion, so because of the motion, the first segment length decreases. So this is the first segment. So here wedge is moving from here to here. Now first segment length decreases by x. First segment length decreases by x. Then second segment. So as the wedge is moving to left side, the block is moving down the inclined plane. So as the block is moving down the inclined plane, now length of the second segment increases. So as the length of the first segment decreases, now length of the second segment increases. And we know ideal string, so total length always constant. So what is the length of first segment? How much it is decreased? First segment length, how much it is decreased? This is second segment increased by same value. Then only the total length will be constant. So when the wedge is in motion, travel through distance x, now this total first segment length decreases by x. If first segment length decreases by x, second segment length increases by y. So how much decrement in the first segment, the same increment in the second segment, then only the total length of the string will be constant. Okay, write down the point. Write down. As the wedge is moving leftwards through distance x length of the first segment decreases by x, and length of the second segment increases by y. Length of the second segment increases by y. So here I'm taking length of the first segment decreases by x. Okay, that means minus x I'm writing. So this minus indicates decreased. This minus indicates decreased by x. Now, what is the length of this second segment? Length of this second segment, it is plus y. Okay, so plus means because second segment length is increasing by y. Okay, so first segment length decreased by x, so minus x. Second segment length increased by y. Increased means plus. But we know that it is an ideal string. So in the case of ideal string, the total elongation. So generally in the case of ideal string, no elongation takes place. So total elongation is 0. If a total elongation 0 means in the first segment, how much change? In the second segment, how much change must be equal to 0. Then only the total length always constant. Okay, in the first segment, so how much change we have? Minus x. In the second change, so in the second segment, how much change we have? Plus y. But the total elongation equal to 0. Why total elongation equal to 0? Because it is an ideal string, no elongation, no compression takes place. Therefore, minus x plus y equal to 0. That means y equal to x. I'm differentiating with respect to time on both sides. Now we get dy by dt equal to dx by dt. But what is the meaning of dx by dt? So here x indicates distance traveled by the wedge. Okay, x belongs to wedge. So here dx by dt means this dx by dt is nothing but velocity of the wedge. But in the question, what is the velocity of the wedge is given, that is v. In the same way, dy by dt. So here, what is the meaning of y? Y indicates block. Y belongs to block. Distance traveled by the block down the inclined plane. So this y distance belongs to the block. Therefore, dy by dt. So it is a velocity, but this velocity belongs to the block. Dy by dt, this velocity belongs to the block. So in the place of velocity dy by dt, I am writing velocity. But whose velocity? Block velocity. But it is wrong. It is not the block velocity. It is a block velocity with respect to wedge. Why? Because the block is moving along the wedge. So whatever velocity it has, okay, so why? Because it is moving along the wedge. This block is moving along the wedge. So whatever velocity it has, that is with respect to wedge. Therefore, this dy by dt, is nothing but velocity of the block with respect to wedge. Okay, write down please first of all. Therefore, finally here what we got? Velocity of the block with respect to wedge equal to v. So you try to get this logic point. So here finally it is the block. This block is moving along the wedge. So it is a dy by dt. This dy by dt is nothing but velocity of the block with respect to wedge. It is velocity of the block with respect to wedge, and this velocity we got as v. But here one more important point. So whatever we got velocity, that is the velocity of the block with respect to wedge. So velocity of the block with respect to wedge. So it is a dy by dt value. So that is the velocity v, we got it. But at the same time here, it is given one thing. This block is always in contact with wedge. That means this block also possesses one more velocity. Why? Because so here, if the wedge and the block are in contact, if the wedge is moving to left side, so block also having velocity left side. Why? Because it is given that block and the wedge are always in contact. Okay, If the wedge is moving to left side, so block also having one more velocity left side. One more velocity. So the same block, it is having one more velocity left side. So this velocity v is because of contact of the block with wedge. Therefore here, so this block is having two velocities. One velocity is because of elongation, this type of motion, first segment, second segment. So moving by distance x, moving by distance y. So because of the changes x and y. So because of the changes, we have one velocity. So because of changes, one is increasing, one segment length is increasing, one segment length is decreasing. So because of the changes, we have one velocity. And because of the contact, so because of contact, this block also having one more velocity. So now we have to simplify this figure further. And in the question, angle of inclination is given theta. So here angle of inclination, this angle of inclination is given theta. So we have to simplify further. We are simplifying further. So just imagine that if this angle is theta. So here, this angle is theta. If this angle is theta, so then what is the angle over here? What is the angle over here? This also theta. This also equal to theta. The same logic let us apply over here. So this angle also equal to theta. Now this velocity resolve into component. Now this velocity is v. I am resolving into components. Now this component is v cos theta and this component is v sin theta. Therefore, in the case of block in x direction, it has two components. In the case of block in x direction, it has two components, and in y direction only one component. Therefore, velocity of the block. So in the case of block, so therefore velocity of the block in x direction is, so finally here, the wedge is moving with velocity v. So this velocity is greater, this velocity greater. So this v velocity greater. So v cos theta smaller, because we know cos theta less than 1. Cos theta less than 1. So this value less than v. Cos theta less than 1. So this value less than v. So it is equal to v. This value less than v. So obviously this velocity will be greater. This velocity will be greater. Therefore, what is the resultant velocity of the block in x direction is minus v cos theta. V minus v cos theta is the velocity of the block in x direction. In the same way, in y direction, we have only one component, that is v sin theta. So these are the x component and y component of the block. So this is the question. The only thing we have to understand is which segment length is increasing, which segment length is decreasing. Accordingly, first equation. So whose segment length is increasing, decreasing, accordingly we have to get one equation. And what is the second equation we have? So in this question, this block is always in contact with wedge. The block is always in contact with wedge. So if the wedge is moving to left side, so the block also having velocity left side. So therefore totally the block is having two type of velocities. One velocity is because of the changes in the segment. One velocity is because of changes in the segments. We are getting one velocity. And what is the one more velocity is block is always in contact with wedge. So because of contact, this block also possesses one more velocity. So this is the procedure. Please note that. So initially it seems to be difficult So once we do 1 or 2 questions, then you feel so more comfortable with this model. If this logic is clear anytime, so these questions are given in advanced level. Okay, so these questions you will do within 1 minute time. If the logic is clear, we will do 1 or 2 questions, then you come to know exactly. Right, next example, second example. Next question. For example, it is a vertical support and it is a horizontal support. And here we have a wedge. It is a wedge. So for example, I'm taking, it is block A. So wedge is the block A. So this velocity of block A or wedge A, 5 meter per second. 5 meter per second. And here we have another block. We have another block B. So this is the question. So here in this case, this wedge A is moving to, it is moving rightwards. This wedge A is moving rightwards. Now block B will move upwards. It will move upwards. So for example, here I'm taking, it is a first segment, it is a second segment, it is a third segment, it is a fourth segment, it is a fifth segment, it is a sixth segment. So totally we have 6 segments. Totally we have 6 segments. Okay, just imagine that. So here this wedge A moving rightwards through distance x. Moving rightwards through distance x. Okay, now the question is, so because of the wedge A motion, so because of wedge A motion, we have x distance. Okay, x distance. That means here this VA means dx by dt. This velocity A is dx by dt. So here we can define dx by dt. Dx by dt is nothing but VA. Okay, now the thing is, so it is, for example, 7th segment. It is 7th segment. Okay. Now you please answer in this case. So as wedge A is moving rightwards through distance x. Now first segment length increases or decreases or constant?
Decrease.
As it increases.
Increases.
By
X.
Second segment increases by x. Okay, increase.
So all
here
increase by x.
And this y value, for example, it is y. Now 7th segment is increased or decreased?
So decreased by x.
Decreased by.
So therefore, so how many segments length is increasing? So plus
6 segments.
plus 6x. Plus means increasing. And 7th segment length is decreasing. So minus y.
Decreasing, so minus y.
And but total elongation is equal to
0.
Okay, so now this is the equation we have.
Sir,
From this equation, please.
what you have taken as x?
X is means the distance traveled by this wedge.
Okay.
X is the distance traveled by this wedge because this wedge is in motion now. Okay. So y equal to 6x we got. You do differentiation. Now dy by dt equal to 6 into dx by dt. That implies what is the exact meaning of dy by dt? Only velocity of block B or velocity of block
That's
B
the block
with respect to A.
Velocity of block with respect to wedge.
So therefore, in the place of dy by dt, I'm writing it is the velocity of the block, okay, with respect to wedge, okay. But this velocity present in y direction, in x direction.
Y
This
direction.
block y direction. So it is a block B velocity in y direction. And that is equal to 6 into dx by dt means what is the value? Dx by dt means VA. And what is the VA value already we have given?
30.
So in the place of dx by dt VA, that VA value 5. Therefore, velocity of the block in y direction, that is equal to 30 meter per second. But in the question, it is given that this block B always in contact with A. This block B always in contact with A. So if A is moving rightwards, if A is moving rightwards, B also having one velocity rightwards or not?
Yes, sir.
Yes, sir.
Therefore, what is a block B velocity in x direction?
So equal to VA.
Okay, that is equal to VA. Perfect. That means
So
5
correct?
meter per second. Ah, correct. 5 meter per second. That's it. Therefore, what is the block B velocity is in vector form? We have 5 cap plus 30 g cap.
Sir, it is only 5 in x direction because no other force is present, no other velocity is
So in
present.
this
no?
case, correct. So why? Because
Okay,
here this block B always in contact with wedge. So if wedge is moving,
So it will also move with the
so
same
it also
velocity.
moving
Okay.
with the same velocity, na? Because
Okay,
they are
sir,
in
okay.
contact.
I understood, sir.
Sir,
Please.
in previous question also I did not understand that. So I got that total elongation is equal to 0, but after that you wrote no that 6x minus y is equal to 0. I did not understand that.
This one.
Yes, sir.
So in this case, as the wedge is moving to rightward through distance x, moving rightward through distance x, first segment length increases or decreases? As it is
Increasing.
moving right, increasing means positive, negative.
Positive.
So increasing by how much
Positive.
value? Positive x.
Positive x.
Second segment.
Minus y.
Ambate.
Second segment, how? Why, man? You don't know any basics. So here, if it is moving through distance x, no, it will be affected. Why? Because all the segments are moving horizontally or moving vertically. All these 6 segments. So if the wedge is moving horizontally along the x direction, so it also moving along x direction, 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 along x direction. So so this segment increased by x, increased by x, increased by x. So all the 6 segments increased by x, and 7th segment decreased by y. I don't know how we are getting here y, surprisingly. Right now, next one. Not giving any respect to the person. Talking illegal. Yeah, right now. For you people, just do one question, leave it. So that is better way. So doing many questions, it's not good also in your batch. So do one question, so we can say do all the remaining questions as a homework. No, this method I follow from the next lecture onwards. So doing all the questions in detailed and still people are criticizing. Right on, next question. So in the question, this angle is given theta. It is moving rightwards with acceleration a. Then after, and here we have a pulley. It is connected to the wedge. And this also connected. And here we have another pulley. And here there is a block. So in the question, if the wedge is moving rightwards with acceleration a, we have to find block. We have to find the block acceleration. So it is very common sense, we can understand. So if the wedge is moving rightward, so this block will move up the inclined plane like this. If it is moving rightwards, it will move upwards. So in this case, this point is connected. Same thing, pulley is connected to the wedge. So if the wedge is moving rightwards through distance x, for example, through distance x, it is the first segment, it is a second segment, for example, it is a third segment. It is third segment, and for example, this distance, let it be y. This distance, okay, let it be y. So as the wedge is moving rightwards through distance x, now first segment length increases by x, second segment length increases by x. Why? Because they are in contact with the wedge. Okay, so if the wedge is moving rightwards through distance x, first segment length increases by x, second segment also. Why? Because they are horizontal. So first segment length increases by x, second segment length increases by x, but third segment length decreasing by y. Third segment length decreasing by y. So first segment increasing by x, then after second segment increasing by x, then after third segment decreasing by y. Therefore, what is the total elongation is plus 2x minus y, but total elongation 0. So total elongation 0. Therefore, by simplifying, we get y equal to 2x. Y equal to 2x, you differentiate 2 times. First of all, if you differentiate 1 time, we convert into velocity. You differentiate 1 more time, so we get into acceleration. So therefore, now in this direction, so y we are getting here, this is y. So this accelerate. So I'm differentiating 2 times. Now this y value, x value, they convert into acceleration. So I'm taking, by differentiating 2 times, it is an acceleration equal to 2 times this x. So dx by dt, one more time d square x by dt square. So this differentiation 2 times, we get this x value. Differentiation 2 times, we get this acceleration. Therefore, this ay equal to 2 times a. But this ay, this acceleration is because of y change. Now this acceleration is present in this direction. dy by dt will be present in this direction. So dy by dt will be present in this direction. So whatever the acceleration I'm getting, that acceleration will be in this direction. It is a 2a. Then after, so now this acceleration is because of the changes, increments, decrements. So because of increments, because of decrements, because of the changes, we are getting this acceleration. At the same time, so here, this block always in contact with the wedge. So if wedge is moving horizontally rightwards, now it is always in contact. So this block also having horizontally acceleration because they are in contact. So because of contact, the block also having one more acceleration a. Now this acceleration a is because of contact. This acceleration is because of contact. Therefore, if this angle is a theta, so that theta also already given, this theta value already given, okay? So this theta already given. Now 2a resolve into components. Now this component is 2a cos theta. Then after this component is 2a sin theta. This component 2a sin theta. Therefore, in the case of block in x direction, in the case of block, okay, for this block, in x direction, we have two accelerations, in y direction, one acceleration. Therefore, in the case of block, what is the resultant acceleration in x direction is a plus 2a cos theta. Y plus I'm writing because both accelerations in the same direction. These two accelerations in the same direction. In the same way, in the case of block, acceleration in y direction, that is 2a sin theta. For example, if options are given in vector form, now what is the acceleration of the block in vector form is x component and y component. Both we have to consider. So a plus 2a cos theta, it is an x component, so I cap. And what is the y component is 2a sin theta. 2a sin theta j cap. If options are given in vector form, so it is a correct option. It is acceleration of the block. For example, if options are given in magnitude form, now we are finding acceleration of the block in magnitude form. So you know very well how to find the magnitude of a vector, root over I cap coefficient whole square plus j cap coefficient whole square. So a plus 2a cos theta whole square plus j cap coefficient, that is 2a sin theta whole square, and we will do simplification. Now, depending upon options, we can proceed. So this procedure in option. So for example, if components are given, so it is the correct option. If options are given, if options are given in vector form, so it is the correct one. If options are given in magnitude form, so it is the correct one. But you try to get the procedure. There is nothing difficulty. The only thing is this segment is increasing, decreasing. So that identification is very, very important. So here we got y equal to 2x, y equal to 2x. If you do differentiation, dy by dt equal to 2 into dx by dt. You do one more time differentiation, we get d square y upon dt square equal to 2 into d square x upon dt square. I hope you know double differentiation. In the chapter calculus, you done it. This y equal to 2x, you differentiate one time. So dy by dt equal to 2 into dx by dt. You do one more time differentiation, d square y by dt square equal to 2 into d square x by dt square. Now x value changing with the time. This x value changing with the time. So it is the corresponding acceleration a here. So because of x changes, we have the corresponding acceleration a. So in the place of d square x by dt square, okay. So it is nothing but 2 into d square x by dt square means a. In the same way, d square y by dt square, this also acceleration. But this acceleration is because of y change. This acceleration is because of this y. So y change. So that's why here I'm writing ay. This acceleration is because of the y change. And rest of the parts, okay. Yeah, note down please. So it is a wedge. And here we have a pulley. And here we have a block. So these are the fixed pulleys. Proper figure. So in the question, so this wedge is moving leftwards. Wedge moving leftwards with acceleration E. Wedge moving leftwards with acceleration E. And for example, this block is moving down. So here this wedge is moving leftwards. This wedge is moving leftwards with acceleration A. So I'm taking it displaced through distance x. Displaced through distance x. So for example here, this block moving down through distance y. Block B moving down through distance y. Same thing we have to find. So here this block always in contact with the wedge. This block always in contact with the wedge. So we have to find the block acceleration. So wedge acceleration is given. Wedge acceleration is given, and we have to find the block acceleration. So in this case, these are the fixed supports. They don't move. These are the fixed supports. So here, just you just imagine that. So it is the first segment. It is a second segment. It is a third segment, and it is a fourth segment. Then after it is a fifth segment. It is a sixth segment. Then after it is a seventh segment. So totally we have 7 segments. So this is a fixed support. This is a fixed support, and these are the fixed pulleys. These are the fixed pulleys, and same thing. It is a fixed pulley. So here, okay, first to draw the figure. I need some space. Okay. I'm taking the first segment. First segment. So here the wedge is moving leftwards. Wedge is moving leftwards. So first segment length decreases by x. First segment length decreases by x. Then after it is a fixed pulley. It is a fixed pulley. They are not moving. So they are not moving. So this is distance constant. So this is the fixed pulley. This is the fixed pulley. So distance between them is not changing. So distance between them is not changing. So for second segment, no change. So equal to 0. So it is a fixed pulley. It is a fixed pulley. They are not moving. So here this distance is not changing. So no change. So equal to 0. In the same way, third segment. So it is a fixed support and a fixed support. So fixed pulley, and this also fixed pulley. So these two are fixed pulleys and fixed support. Now this distance also no change takes place. So this is third segment distance, no change. So third segment x value 0. Then after coming to fourth segment, fixed pulley, this distance. Okay, no change. Why? Because fixed pulley and fixed support. So this is fourth segment distance, no change. So for the fourth segment, no change, so equal to 0. Then after, so here the wedge is moving, to leftwards. If the wedge is moving leftwards, so here if the wedge is moving leftwards, this pulley also moving leftwards. Why? Because this pulley is connected to wedge. This pulley is connected to wedge. So if the wedge is moving leftwards, this pulley also moving leftwards. So it is a fixed pulley. It is a fixed pulley, but in this case, as the wedge is in motion, this pulley also in motion. Therefore, what is the fifth segment length increases because of wedge moving to left side. If wedge moving to left side, this fifth segment length increases. So therefore, for fifth segment, length increases, so plus x. So then after sixth segment, so coming to sixth segment here, same procedure. So both are, so in this case, this is sixth segment length also no change. Sixth segment length also no change. So for sixth segment, no change equal to 0. Then after seventh segment, now this is seventh segment is moving down by y. So this is seventh segment length increases by y. Seventh segment length increases by y. So increasing by y, so plus x. So plus y, sorry. So seventh segment, this segment length is increasing, so plus y. So all the segments we completed. Okay, so therefore, what is the total elongation equal to 0? Because ideal pulley. So total elongation, okay, that means minus x for the first segment, 0 for second segment, third segment 0, fourth segment 0, fifth segment plus x, sixth segment 0, and the seventh segment plus y. So it's the total elongation equal to 0. Therefore, minus x plus x cancel out. Therefore, y equal to 0. If y equal to 0 means, so you do 2 times differentiation. That means what is the acceleration because of change y equal to 0. Okay, that means this block has no acceleration in this direction. Why? Because y value we are getting 0. Y value we are getting 0 means in this direction. In this direction, no acceleration is present. Y value we got 0. Okay, so y value 0 means no change. So no change in this direction. If no change, so no acceleration. So no acceleration present. But so that means if block B acceleration completely 0, this block B acceleration completely 0, no. Okay, why? Because still here this block B is in contact with the wedge. So because of contact, if wedge is moving leftwards, so this block B also moving acceleration leftwards. But because of changes, no acceleration is present to the block. Okay, so because of changes, no acceleration is present to the block. But because of contact, so because of contact, this block B, it possesses acceleration. So therefore here, this acceleration 0 means due to changes in the segments, block B is not getting any acceleration. Block B is not getting any acceleration. Block B is not getting any acceleration. But due to contact of the block, with wedge, acceleration of the block is So in this case, due to contact of the block with a wedge, so as the wedge is moving leftwards, wedge is moving horizontally leftwards, this block acceleration horizontally leftwards. This block also having acceleration leftwards. So acceleration of the block is A, horizontally leftwards. Horizontally leftwards. So this is the question. So in this case, because of changes in the segments, this block, okay, this block is not having any acceleration. It is not having any acceleration, but still one acceleration present, that is because of contact. So because of contact with the wedge, this block possesses one acceleration. That acceleration is A, direction is horizontally leftwards. Okay, write down one last question. Okay, only 2 minutes. One last question, right now. For example, it is a wedge. It is a wedge A, for example. It is moving leftwards, so rightwards with acceleration A. Moving rightwards with acceleration A, and here it is a pulley. It is connected to a block. It is connected to a block. Now block B is in contact with the wedge. Block B is in contact with a wedge, and here we have a pulley, and here we have a pulley, so draw the figure. Now we have to find the acceleration of the block. So in this case, for example, wedge A moving rightwards through distance x. Okay, that means here this acceleration E. This acceleration is d square x by dt square. This acceleration is d square x by dt square. So this acceleration is d square x upon dt square. Now let us identify, for example, it is the first segment, it is a second segment, it is third segment, it is fourth segment, it is fifth segment, it is sixth segment, it is seventh segment. If the wedge is moving rightwards, the block will move through distance of y. The block is moving up through distance of y. So here, if the wedge is moving rightwards through distance x, this is a first segment length. Okay, so as the wedge is moving, now this point also will move rightwards. This point also will move rightwards through distance x. This point also will move rightwards through distance x. This point also will move rightwards through distance x. So this type of changes will happen. Okay, so if the wedge is moving rightwards through distance x, so first segment length increases. So x1 becomes plus x. Then after, it is a fixed pulley. So it is a fixed pulley. So this distance doesn't change. So here, no change in the second segment, no change in the second segment, so that is equal to 0. Then after, so third is because of wedge motion. Because of wedge motion, now third segment length increases, fourth segment length also increases. Now third segment length increases by plus x, and the fourth segment length also increases by plus x. So because of wedge motion, this point is in motion. If this point is in motion, now this length increases by x, this length also increases by x. Now coming to fifth segment. So it's a fixed pulley, it is a fixed pulley. So sixth segment, no, so it is a fifth segment, no change. Fifth segment, no change. In fifth segment, no change. Then after in sixth segment, so here, so as the wedge is in motion, this pulley also moving. So sixth segment length increases by x, but seventh segment length decreases, so by y. This is seventh segment length decreasing by y. But what is the total elongation? So total elongation 0. So first segment plus x, second segment 0, third segment plus x, fourth segment plus x, fifth segment 0, sixth segment plus x, seventh segment minus y, a total elongation 0. If we simplify, we get y equal to 4x. Y equal to 4x, you do differentiation 2 times, then we get d square y upon dt square equal to 4 times d square x upon dt square. And already I told you that d square x by dt square value is a. D square x by dt square value is a, and d square y by dt square is acceleration. This acceleration is because of changes in y. D square y by dt square is the changes, that is the acceleration due to changes in y. So therefore, I'm keeping d square y by dt square as it is, equal to 4 into, already we have d square x by dt square means a. D square x by dt square, that is equal to a. Therefore, this acceleration is present in y direction. This acceleration is present in y direction. Now it is a value of d square y by dt square. D square y upon dt square, this acceleration is equal to 4a. Now this acceleration is because of changes in the segments. This acceleration because of changes in the segments, but also we have contact. So due to contact, so here due to contact, so as the wedge is moving rightwards, so due to contact, block B also having acceleration rightwards. Okay, so block B also having acceleration rightwards. So this is the question we have. So finally here in the question, okay, only 2 more minutes. This angle is given theta. This angle is given theta. So this angle is given theta. If this is equal to theta, now this angle is equal to 180 minus theta. 180 minus theta. Therefore, it is one acceleration. Between the 2 accelerations, what is the angle is 180 minus theta. Between this acceleration, the angle between them is 180 minus theta. Angle between them 180 minus theta. So you follow parallelogram law to find the magnitude of resultant acceleration, that is root over a1 square plus a2 square plus 2a1 a2. So between the accelerations, what is the angle is 180 minus theta. So one acceleration is a. So for example, it is a1 value, and for example, it is a2 value. And between the 2 accelerations, the angle is 180 minus theta. So therefore, root over a1 square. So root over a1 square, so that is a square, and a2 square means 16a square plus 2 into a1 is a, a2 value 4a, cos of 180 minus theta is minus cos theta. You simplify, so that is the final equation. So it is about accelerations. Yeah, class is over. Well, just you practice once or twice, so we come to know very easy. So I have on the same model, I have 5 to 6 questions more. So I will send you in the group. So you practice those questions also. Okay. So bye.